So first, we'll solve the questions from October, November 2019, paper 4, value 1. Selective topic, which is about empirical formula, molecular formula, and the modes. So in the first question, sulfur dioxide reacts with sodium sulfide to produce a compound which is having the following composition, like it contains 29.1% of sodium, it contains 45 or 40.5% of sulfur, and remaining it contains oxygen. So we have to find the empirical formula. What are the steps for finding the empirical formula? We divide by atomic mass, then we divide by the smallest value, and after that we round off. We have sodium, which is Na, that is 29.1%. We have sulfur, which is 40.5, and then we have oxygen, that is 30.2%. So first, what we do, we divide by atomic mass. For atomic mass, we use a periodic table. The periodic table you will find for sodium, that is 23, sulfur is there, that is 32, and oxygen is there 16. So 29.1 divided by 23, sulfur is 40.5 divided by 32, and oxygen 30.4 divided by 16. What is the answer when 29.1 divided by 23?
1.265.
1.265. What about 40.5 divided by 32?
1.265.
1.265. And 30.4 divided by 16.
1.9.
1. So this is the step 1. We divide by the relative atomic mass. Step 2, we take a simplest ratio. So what we do, we divide by the smallest value in the combination. So the smallest value in the combination is 1.26. So we'll divide all of them by 1.265. So this will be divided by 1.265, 1.265, 1.265. So this will come out with 1. This will also be 1, but what about 1.9 divided by 1.265? How much?
1.5.
1.5. So whenever one of the values 1.5, 2.5, 3.5, what we do, we multiply all the numbers by. When we multiply all of them by 2, then this will be 2. It will also be 2, but this will be. So the formula, the empirical formula of this compound is contained by ratio. It contains 2 atoms of sodium, the simplest ratio, 2 atoms of sulfur, and it contains 3 oxygen atoms. So formula is Na2S2O3. Is it clear? Then another question. This was empirical formula question from October 19 paper. Then this question is related to the moles concept. In the question, a dilute hydrochloric acid HCl which react with sodium carbonate gives a form like Na2CO3. So HCl plus sodium carbonate gives NaCl plus CO2 plus water. 25 cm cube of proportion of sodium carbonate is there, which was placed in a conical flask, and few drops of sodium indicator is added. It was titrated against hydrochloric acid with a concentration 0.18. 20 cm cube of hydrochloric acid is required to reach the endpoint is completely reacted. Calculate the number of moles of HCl used. So we have the concentration and we have the volume. How to get the moles?
Multiply them.
So we'll multiply them. So moles equal concentration into volume. And the concentration is 0.18. Volume is in cm cube, so we have to convert into dm cube. We divide by 1000. What's the answer? 0.18 multiplied by 20 divided by 1000. So 0.18 times 20 divided by 1000.
Zero point 0036.
0.0036 moles of HCl are used. Then calculate the number of moles of sodium carbonate. So first we solve by formula, the second one we'll solve by ratio. We'll take a ratio between hydrochloric acid and sodium carbonate. So according to equation, the simplest ratio for reaction between sodium carbonate and HCl is 2:1. So if we have 0.0036 moles of HCl, X moles of sodium carbonate. So we cross multiply, X will be equal to 0.0036 divided by 2. So means it will be half of the previous answer, which will be 0.0018. Now we need the concentration in mole per dm cube. So concentration in mole per dm cube, mole divided by volume. Moles of sodium carbonate, we calculated 0.0018, and the volume of sodium carbonate, it was 25 cm cube was used, so it means 0.025. So it should be 25 divided by 1000, which is 0.025. 0.025. So when we divide these two, we'll get the concentration. What's the final answer? 0.0018 divided by 0.025.
0.072.
So 0.072 is the concentration of this solution. So 0.072, and the unit of the concentration is mole per decimeter cube. So first, we were having the volume and concentration of HCl. We work out the moles. Then from using a ratio, we work out the moles of sodium carbonate. And from moles of sodium carbonate in volume, we got the concentration of sodium carbonate.